In this lesson, we're going to be looking at both cones and pyramids, but we will just be finding their volume. And volume is the inside of the shape. So if I were to fill it up with something, how much would it take to fill up is the volume of it. The base is the bottom. Now that doesn't mean that it's going to be sitting on its base. It might be sitting sideways or turned upside down. So keep that in mind. But especially with these two shapes, cones and pyramids, the base is always going to be the flat side. Like for example in number 2, this cone is actually flipped upside down because we see the flat side, that circle flat side is on the top, but that really is the base. So we're looking for that flat side in these two shapes. And then we've got a bunch of different formulas here. We have our volume formulas. And in these volume formulas, we're actually not going to use the sphere right now. We'll look at that in another lesson. But we have this capital B in both of these. And it says that capital B means the area of the base. So that is why we have these other formulas over here. Area formulas for calculating capital B. So anytime you see capital B, that does not represent one single thing. It means you have to do some other calculations, find the area of that base using these formulas. If it's a rectangle, you have to find the area using that formula. If it's a triangle, or if it's a circle. So our first step is always going to be to find the area of the base. And then we'll plug in all values and solve. Okay, so let's look at number 1. We have a cone, and in this cone, the circle is the base. So that means to find capital B, we have to find the area of a circle. And the area of a circle is pi times radius squared. It gives us the radius is 0.8. And then pi is 3.14, so we have 3.14. And then we're going to multiply that by the radius, which is 0.8, and the radius has to get squared as part of that formula. So then in our calculator, we're going to find 3.14 times 0.8 squared, and that is going to be 2.0096. Now it does go out a little bit far, but because it terminates, I'm going to go ahead and write down all those numbers instead of rounding, because the less we round, the better off, the more accurate our answer is going to be. Okay, so now that we found the area of our base, now we're going to go to our volume formula, and we are looking at a cone here. So we're going to be looking at the cone formula. So volume of a cone is 1/3 capital B, which is area of the base, times the height. So for us, we're going to take 1/3 times, well, we already found capital B. The area of our base, or capital B, was 2.0096. So that's capital B, and then we have to multiply by the height of this cone, and the height of our cone here is 12. From the base up to the point is 12 millimeters. Oh, and for the sake of this problem, just since we're practicing, we're just going to pretend that these are both in the same units. Technically, we would need to convert them into the same units, but just for the sake of practice here, we're going to say they're both in millimeters, in the same unit. And then I would multiply that by the height, so that's 12. If you're using the Desmos calculator, you can go ahead and put that all in there together. For me, I'm just using a regular calculator, so I'm going to take the 2.0096 times 12 first, and then I'll divide that by 3 because that's the same thing as multiplying by 1/3. And we get 8.0384. And then we said that was going to be in millimeters, and volume is going to be units cubed. And we can write a note off to the side here that volume equals unit cubed, so to the third power. All right, let's look at number 2. Again, one is yards and one is feet. We would really need to convert these to the same unit. We would either need to convert yards into feet or feet into yards. For the sake of practice, what we're trying to practice today is just finding the volume. We will look at examples later on how to convert those to the same unit. So for the sake of practice right now, let's just say that these are both in feet. Again, that is just for the sake of this example. Normally you would have to convert that to make sure they're in the same unit and not just change it like I did. Again, we're going to start by finding our capital B. So our capital B this time, we're looking at a cone. So the bottom is this circle, the base is this circle. But it gives us the diameter all the way across is 10. And you take the diameter and divide it by 2, and that'll give us our radius. So 10 divided by 2, the radius is going to be 5. And we're looking at the area of a circle again. So that's pi times radius squared. So for us, it's going to be 3.14 times 5 squared. And I'm going to put that in my calculator. And that is going to give us 78.5. And then once we have our capital B, then we can go plug it into our volume formula. So the volume is 1/3 times capital B times the height. So the 1/3 is going to stay 1/3. We already found capital B. The area of the base was 78.5. Now the height is 36. And then once we've got that all plugged in, it's just plugging it into the calculator. And we get 942. And we said this was going to be in feet, so it'd be feet to the third. All right, that's it for cones. Now we're going to look at some pyramids. We have 2 different kinds of pyramids. If you look at number 3, the bottom or base of this pyramid is this triangle. And in number 4, the bottom or base is this rectangle. So we're going to use 2 different formulas to solve these. So number 3, to find capital B, we have to find the area of the base. In this case, the base is that triangle. So we need the area of a triangle, which is 1/2 base times height. Now notice this is little b and this height. So we're talking about just the base. I'm looking at just this pink triangle that I outlined here. So we don't need the height of the whole pyramid yet. We're just looking for the height of that triangle. That's what that H stands for here. So that's going to be 1/2. We said height and base of a triangle have to be perpendicular, and we can see that 90-degree angle here. So that's going to be, the base can be the 7, and the height can be the 15. And then we're just going to put that in the calculator. And we get 52.5. Now that we have our capital B, now I can go ahead and solve the rest of it. So my volume formula for a pyramid is going to be the same as for a cone, 1/3 times capital B times the height. Now this time that H stands for height of the pyramid, since this is the pyramid formula. So then we're going to take 1/3 times the capital B we found was 52.5. And now our height of our pyramid is 18. I'm going to multiply all that together in the calculator. And we get 315. This is in meters, so it's going to be meters cubed, or meters to the third. And then for our last one, again, we got to start by finding capital B, the area of the base. And we said in this case, the base is going to be a rectangle. So I need to find the area of the rectangle. And the rectangle is 19 by 3 rectangle. So 19 is the length, times 3 is the width. And that's going to give us an area of 57 for the area of the base. Once we have the area of the base, we go back to our volume formula. 1/3 base times height. Sorry, 1/3 area of the base times height. So we have the 1/3. Our capital B area of our base we found was 57. Now this h represents the height of the pyramid, which is 8. And then we just multiply all that in our calculator. And we get 152, and this is in centimeters, so centimeters cubed, or to the 3rd power. So always remember that when we're finding volume of these shapes, cones and pyramids, we need to find capital B first. So find the area of the base first, and then we'll use that to plug in to the formula. So there's a capital B every time. We have to calculate that first before we can start plugging into the volume formula.